He's at the back.
Right? The one in the black shirt? Is it? Is that him?
Wait. The guy in the collared t-shirt.
Right? And then the first speakers are here. And then one is coming at 7. John is coming at 7. And where are the other ones?
This is so hard.
Oh, do we know when is Rachel coming?
Sorry?
Do we know when Rachel is coming?
As in, no.
Wait, she's coming today, right?
Yes.
Okay, okay.
As in, like, you should keep a tab on, like, whoever's coming.
Yeah.
I wouldn't know because I don't have the contact.
No, I mean Rachel, like.
Yeah, as in, I wouldn't, like.
Okay, should I text her? Okay, let me text her. Oh, okay. Ooh. I think that's. We're about to kick off the event. Why is this? Can everyone hear me? Okay, perfect. Okay. So, hi guys, I'm Ronnie from Mello Research, and for those of you who are new, we host the monthly Singapore AI Showcase. And for those of you who have been to our events before, thank you for coming again. And as an introduction, I will just pass around the mic for everyone to introduce themselves. Just introduction.
Okay.
Yeah, just like your name, like what you do.
Okay. Hello, my name is Yoshi from Practice International Private Limited. We are asteroid mining company based in Singapore.
Just pass it.
Hi everyone, I'm Jay from Beacon Venture Capital. We are a corporate venture capital arm under Kasikorn Bank based in Bangkok, Thailand. So we basically invest in post-revenue startup. Yeah, looking to connect with everyone here.
Hi, I'm Book, same company as Jack.
Hi, I'm Ziken Zeng. I think our first year was AI program manager. I met Nicola last week, right? As AI, like the AI event. Yeah.
Hi everyone, I'm Manu. I'm from India. I'm an undergrad student, just looking to explore ideas. So, thank you.
Hi, I'm Ong. I just started a new startup with Antler last month, and I met with Ronnie at Antler and just coming here to explore what other presenters are presenting.
Hi everyone, my name is Jovin. I'm an AI and MLOps engineer.
Hi everyone, I'm TK, doing a bit of computer vision related stuff.
Hi everyone, I'm Justin. I'm a year 2 NUS student and I'm interning as a data scientist right now.
Hi everyone, I'm Sing Tong. I'm a student at NUS and I look forward to learning from everyone here.
Hi everyone, I'm Anuj. I recently exited from a tech startup. I'm here to meet new people and see what's happening.
Myself, Nishant. I'm a techpreneur, build a couple of products on AI agents.
My name's Albert Phelps, co-founder at Tomorrow. Going to be chatting in a second, so I won't take up too much time.
Hi, I'm Nena. I come from Indonesia. I come here for explore about AI.
Hi, I'm Karthik. I'm a student from NTU.
Hi, I'm Justin. I also look into computer vision stuff.
I'm Ethan. I'm a student. Yeah.
Hi, I'm Zoyan. I'm here to learn. I'm an engineer.
I'm Jacob. I do some independent research on crypto AI and run a report.
Hello all, I'm Om and I'm a passionate AI and dynamic learner.
Hi everybody, I'm Jay and I run Studio Mesco. It's a UX design studio based out of Singapore and India, and we help AI and SaaS companies design their digital experiences.
Hi, I'm Alan. I'm from Savills as a real estate consultancy. I'm interested in AI and quantum information systems.
Hi, I'm Prashant. I work with Meta. I cover strategy for India. I'm here just to learn about AI.
Hi, I'm Haron. I'm doing a humanoid robotics startup.
Hello everyone, my name is Hector. I'm from Mexico. I'm a wildlife director and cinematographer, blue chip content creator.
Hi everyone, I'm Eric. I was actually at Antler last year. Right now I'm working on my startup. It's called Firebase. We're basically Supabase combined with Replit or vZero. Also, I have some cloud credits in case anyone want to burn some cloud credits or collab on some cool shit. So hit me up.
Hi everyone, I'm Denny. I'm running peer-to-peer real estate rentals marketplace similar to Airbnb, and I'm looking for collaborations, partnerships at the intersection of AI and travel.
Hello everyone, I'm Mauricio from Peru. I have a business that
help other businesses to solve their problem with AI, especially as a software engineer. There is a new possibilities to open that. If you have a business and need to solve something with AI, maybe you can work on that. Thank you.
Hi everyone, I'm Jashan. I work at Menlo in the robotics division.
Hi everyone, I'm Nicole. I'm also at Menlo.
Hi everyone, my name is Kian. I operate AI education service in South Korea. It's a pleasure to meet you. Thank you.
Hello, I am Sunyeon from South Korea. I run an AI education business named AI Jong. Although my business isn't very strong, I'm confident I can promote your SaaS product in Korea. Excited to collaborate with you. Thank you.
Hi, my name is Joshua. Gavin and I are trying to experiment with fetal health and trying to improve lives of expecting mothers and babies. And with the buzzword of RAG, of course, everything's with RAG, right? So, thanks.
Hi everyone, I'm just the guy who's trying to make his dream happen. So, doing whatever I can to learn the prototype.
He's a front end.
All right. Yeah.
Hey everyone, I'm Daniel. I'll be presenting later about Gen. So I'm from Menlo, I'm an intern there, and yeah, I'm helping to run the live stream.
Hi everyone, I'm Brandon. I'm a forward deployed engineer with a Canadian defense adjacent consulting company. I work in AI solutions, recently mostly computer vision and time series signal processing kind of stuff.
Hello everyone, I'm Valencia. I'm also from Indonesia. I just came here to learn more about AI, and I also work in multinational companies, specialized creating like customer program, like reward company.
Hey guys, my name is Artem, co-founder of e-commerce community for consumer brands. We are interested in technology of marketing in e-commerce. If you are from SaaS or in the enterprise consumer brands, let's catch up. Interesting to know your ideas.
Hi, my name is Rahmiddin, and I'm a student at SIO.
Hi, I'm Elvin. I provide advisory in the intersection of business, risk, and technology, analytics, sustainability, social impact, ventures, startup, financial risk management. These are all my domains, and I leverage on intersecting to create these advisory, observation, strategy, innovation. Thank you.
Do you want to do an introduction?
Alright, hi, I'm Kevin. I'm the librarian at the National Library. It's my pleasure to host Menlo once again this month and every other month all the way to the end of like the year for this kind of AI showcases, right? So at the library we're trying to bring in a different kind of crowd, bring in practitioners and professionals to kind of talk about industry level stuff. So this session is a little bit different from kind of programs you see at public libraries, and we hope that it's a bit more interesting for you guys who are in the industry, as well as maybe some of the students or anyone who's basically interested in AI but may not necessarily be already in the space. So hopefully you guys get to just experience a little bit of what Singapore has to offer and what the world has to offer and gain something out of it. Yeah. So thank you very much, and I'll pass the time back to Ronnie.
Thank you. So without further ado, I think I'll pass the floor to our first speaker, Albert.
That's great, thanks a lot. Oh yeah, I can just hold this. I mean, do we have a
No,
clicker
I
there?
don't think so. Yeah, we don't.
No worries. I'll just go and get my mouse. Great. Well, thanks so much for having me today. I'm going to be as quick as I can. I can have a bit of a habit of blathering on, so I'll do my best. So, systems.models taking AI agents to production. Hopefully, what you get out of this session with me is a bit of an understanding of what we do here at Tomorrow,
some patterns to deploy to enterprise with AI agents, the buzzword of feels like the year, if not the decade. Yeah, we'll go through it as we go. In terms of stuff about me, I'm a co-founder here at Tomorrow. We are an AI consulting and engineering company that was founded in November 2023 in partnership with OpenAI. We work with companies around the world to build first-in-the-world AI agents into production, clients such as the NBA, Supercell, Fidelity International, and others. In terms of my role, I look after research and development at Tomorrow, and I also recently opened the Singapore office for us as well, and lead our APAC presence from here. So, what should we think about when we're building with large language models? I think the first thing that we need to get rid of is this idea that they are mere stochastic parrots repeating what they've read on the internet. There's a famous paper by Emily Bender and Timothy Cabrew in 2021, which really tried to poo-poo the whole nature of large language models as actually being, useful, relevant, intelligent. I think the proof really is in the pudding, so I don't need to dwell too much on rebutting them. When I gave this talk, or a version of this talk, a couple of years ago, about a year ago, over in Dubai, I was very confident in also saying that large language models were not superhuman reasoners. I think with the likes of O3, O3 Pro, and beyond, maybe I'm starting to question this particular slide. But fundamentally, that we're not at AGI yet, I guess is a way to think about it. What I'm going to start with here is just maybe to try and show you the difference between a reasoning and a non-reasoning large language model. So this is an eval that I've been running on large language models since the days of GPT-3. I know the head of applied research over there quite well, and I always joke with him, when your models get this answer correctly in zero shot, I'll be impressed that they're clever enough for us to build with in enterprise. So the question here is, what links Eugene Onegin and AI? Eugene Onegin is a book by Pushkin, and the link between Eugene Onegin and AI is Andrei Markov. Andrei Markov being the Russian mathematician who used Eugene Onegin as the source to develop his theory of Markov chains by predicting whether the next letter in the sentence was going to be a vowel or a consonant. So you can see here on the left-hand side, GPT 4.1 just comes out with a load of rubbish. Again, a good meta if you're not sort of super familiar with large language models is often the longer the answer, the worse it's going to be. On the right-hand side here, you can see O3 has immediately got that answer correct. So why has it done that? It's because it's spent a little bit of time thinking, running chain of thought to actually get to the correct answer immediately. So I guess what I'd say is reasoning models are a big deal, the hype is real. Why is that the case? It's because model capability continues to improve as we scale compute. We knew that with pre-training, we know that now with post-training. When we think about what we call test time scaling or long thinking or systematic chain of thought, reasoning models, it's given us another access to scale model capability and compute, another way of performing that sort of bitter lesson from Richard Sutton. But don't get too caught up in the hype, right? Like the fundamental nature of large language models hasn't changed. So there's a great quote by Andrej Karpathy here, which is, in some sense, hallucinations is all large language models do. They are dream machines. And yes, that does apply to O3 too. And in a certain sense, O3 is actually a little bit more mendacious because the quality of its answers are so good. You begin to really, really trust every single thing it says, and you're going to have a bad time if you're doing that. It still makes mistakes in roughly the same frequency as earlier models. My best framing, and I think the best way to think about large language models, is that they are simulators. This was proposed in a paper in 2023 by Murray Shanahan, quoting a rather famous prompt engineer called Janus. Look them up online if you don't know them already. But they conceive of large language models as simulators. When you are prompting a large language model, you're creating a simulacra, a character. With your prompt and with the AI response, you're generating a character to do a particular role or task. In enterprise, therefore, we don't think that really large language models on their own are enough. We need to ground them, we need to role tune them with prompts, personalities, knowledge, and tools. and also with the ability, increasingly with agents, to manage their own context window or manage it for them. So what does sort of the anatomy of a single agent in the way that we build one at tomorrow look like? In the middle we have the large language model as the reasoning engine. Around the sides here we have the tools that it has access to, and of course now that includes MCP. We're looking at hooking it up with enterprise knowledge, with software, with business intelligence tools. On the right-hand side, we have the guardrails, where we're doing the logging of the system that we build. We're also, before going anywhere near production, running a significant amount of evals. The left-hand side here, this is really my specialism, is the prompts. So how do we define the role of what we want it to do? How do we elicit the instructions? And how do we manage its conversational memory and its memory of the user? Increasingly, I would say that's being automated. So we're looking at TextGrad, DSPy, all of those kind of things, using large language models themselves to develop those prompts. Previously, that was a very manual endeavor. And then we're thinking carefully about how we do interaction, whether that is human to end user, human to agent, so agent to end user, or agent to agent in a multi-agent framework. There's probably two ways to think of building multi-agent systems that we tend to do. The top one here is like the workflow pattern, so you're using large language models to do classification of user intent. You're then routing them along predefined routes, and then you're providing that route in the context to an LLM agent. That's what I would call sort of orchestration by code. When we're doing high-risk customer service use cases, for instance, we're building with that orchestration by code pattern, or what we call a tomorrow CS pattern. I think I put this down as discover new workflows with orchestrator pattern. We're increasingly building like this, I would say, where we have large language models managing their own context and actually interacting with each other a little bit more autonomously. A really good example of a package, if you want to use one out of the box, that operates like that is something like the OpenAI Agent SDK, which is great fun to play around with. Advantages and disadvantages, the workflow pattern, the logic's encoded in code. The LLM is really only being used for content generation, structure generation, and intent classification. There's an explicit control flow, which means it's fast and cheap, predictable and testable, and it's audit friendly. The challenge is it's rigid on novel queries. It's not always very exciting to interact with. And unless you're really thinking carefully about what those patterns in code are, you can have quite stale or boring UX. Where do we use it? In high-risk production, customer service pipelines, and regulated industries. And what sort of design heuristics? So sort of thinking about it as a code orchestration first. On the right-hand side of Orchestrator, this is where I think the world is going. This is where I'm increasingly building many more prototypes and stuff into production. The disadvantages of it, it's much harder to guarantee correctness. The jailbreak surface is larger, so red teaming and evals become even more important. But this is where I would sort of place my bets in terms of where I think the world is going as modern capability increases. And yeah, as of April, we tend to build with workflow, but we're increasingly using Orchestrator. So our conception as a company and sort of our founding motto is that AI agents are the largest potential driver of competitive advantage for every single business and enterprise in the world today. Some selected examples of what we've built before. So I mentioned before the gameplay support. We're doing player support. We're massively outperforming human agents there, both in terms of time to correct answer, but also customer service. Interestingly, with that use case, that's one where we initially thought it was a sort of a cost-out play, and now it's actually becoming a huge potential revenue driver for that particular firm, as well as we found out that players absolutely love interacting with it. We're doing real-time basketball commentary, which I mentioned before as well. That's using the workflow agent pattern. Some of our other big ones, we're founding Alpha at Global Hedge Fund based out of London. We're processing petabytes of data with LLMs into knowledge graphs and doing some very complex retrieval patterns there with agents to find alpha. And then on the right-hand side, we have a slightly more, I would say, exciting use case, which is first in the world real-time API production-grade system for people that are delivering cans of Red Bull, if you can believe it. And very quickly, I just wanted to show you an example of this sort of workflow orchestration. So here we have the intent classifier. Based on what the player wants to do, we then trigger a particular action, or we do a request for information, and we're doing that famous RAG set here with contextual RAG based on Anthropic paper, which is really good, and generating response. Or if the user's rude or wants to jailbreak us, we give them a small talk or templated response. it's a pretty straightforward workflow, if I'm honest, and very scalable. I just wanted to very quickly give you, it's not really a demo, so I shouldn't have said this, but we basically here have the real-time API as the front end, so this is actually via text or via voice, however you want it. I've asked for a real-time, which is not a particularly clever model. Those of you who've built with the real-time API will know this. I've hooked up a tool in the backend which will allow it to function called O3. Here I've told it not to use the tool and it's come out with the incorrect answer. Over here I've told it to use the tool and it's come out with the correct answer. So in terms of heuristic of how to build these systems, I think multi-LLM, incorporating reasoning into workflows even when using voice as the main way of interacting, I think is definitely something to take away. And then finally, just to say, we're hiring engineers, we're hiring consultants, we're hiring product people, designers, anyone that is really passionate about large language models and AI, and I assume there's many people in this room since you're here. So please, if you want to, scan the QR code and get in touch. And yeah, thanks very much for having me. Pause there for any questions.
Any questions from the room?
Small question. Hi, I'm Jalaj. You spoke about how like reasoning models are a completely different beast and a much more advanced beast than like your normal ChatGPT 4 and stuff like that. So I don't know if you recently came across the paper written by Apple engineers where they've said it's really not much of a big leap. So I just wanted to know what you think about it. And I mean, I haven't gone through it deeply, so just like if you could just let me know how you are tackling that.
Yeah, I mean, don't look to me for a technical refutation. I guess one, my comment would be, of course, Apple would say that. Have you tried using Siri? Secondly, for me, the proof is in the pudding, right? Like I've gone from really having to coach and baby models probably all the way up into like 4.0. Now with O3 Pro, with Claude 4, especially in harnesses like Claude Code or Codex from OpenAI, they're really starting to genuinely add value and contributing to code bases and software engineering. So I almost don't care. Does that make sense? Like we're practically using these tools, they're delivering value, and yeah, I'll sort of leave the theory around it to real scientists.
Just another question on a separate note. When I use deep research or when I use agentic workflows, I've noticed that it's really about the speed, because for a lot of businesses, accuracy has been solved. Like in businesses where you require probabilistic workflows, where you don't require high accuracy, you can already use it in production. So is this only an energy and infrastructure problem, or is it more than that, where a deep research query which takes 10 minutes, how can we take it down to 8 seconds or 10 seconds? Is it only an energy and infrastructure problem, or is there something more there?
That's a great question. I mean, my experience working with enterprises, the tech side of it matters actually significantly less than the human side of it, finding the right thing to do. But specifically on that point with how long deep research takes, I mean, I don't know if you've played with O3 recently, but it's massively sped up. So we're starting to see the Blackwell generation of chips come online, which will definitely solve some of the latency issues that we're seeing. You've got competitors like Grok who've made their entire business model around ultra low latency and agentic workflows. So I think that will be solved, but lower latency doesn't mean that it solves business problems, right? Finding and spending the time to actually understand how humans do their work, and not just slavishly replicating how humans do work, but imagining entirely different workflows. That's the business we're in, and I think that's the really tough part, beyond the tech side.
I don't think we have enough time, but you can get Albert's contact and then ask him later. Make sure you scan the QR code. But
yeah, thanks a lot.
Thank you.
And then next up we have Yoshi, which is not like directly AI related, but I think it's super cool, so I invited him to come as our speaker.
Okay.
everyone. My name is Yoshi from Planetex International Private Limited, based in Singapore. We are asteroid mining company. Yeah, our vision is save the Earth resources by utilizing space resources. Okay. This is my business. We send exploration satellite to asteroid and extract the resources there and bring back to Earth or as a location. Yeah. Okay. On Earth, there are a lot of problems regarding regarding resources. There is a possibility rare metal on Earth will become depleted and environment destruction and child forced labor during mining resources is also a big problem. Actually, demand for platinum is 250 ton per year, but total supply is short of that. We will solve this problem by utilizing space resources. Okay, there are a lot of asteroids, especially we are focusing on near-Earth asteroids. We already discovered 30,000 near-Earth asteroids. There are some type carbonaceous asteroids and stone asteroids, metal asteroids. Metal asteroid contains a lot of iron and nickel and platinums. We focus on platinums on the asteroid. Okay. We focus on our target is between 6 meter and 10 meters diameter asteroids. Already NASA and JAXA go to asteroid and get some kind of sample from back to Earth, total 3 times. And but okay. Actually, OSIRIS-REx, this is a NASA's exploration satellite. Cost 1.5 billion Singapore dollar and get back 100 grams return. So its transportation cost is very expensive. If we get 1,000 ton asteroids, include 1 ton platinums, this worth over 50 million Singapore dollars. But transportation cost is very expensive. So we have a cutting edge solution to solve this problem. Previous exploration satellite involved refueling on the ground. Our exploration satellite go to asteroid involved refueling on asteroid using asteroid resources by as programmed. Yeah, we already calculated we can move 1 ton over 1 tons we can move over 1 tons asteroids within 20 million Singapore dollars. Sorry, our technology is prepares to get patent. Sorry, I can explain the detail. Sorry. our first launch is 2028 and 2031. This is a real commercial missions, and we can try increase satellite amount of satellite. Okay, thank you.
Questions from the anyone has specific questions, or is it anyone? Do you have your website that you want people to like go check out or follow? That you want to show on the screen right now? Well, people your website. Do you want to show them?
Oh, what's
Or-
website?
Oh,
There's a question.
Oh yes.
Just wondering, how are you going to do the registration and shipping? Shipping the lines back to us?
Okay, back to us. Return Technology has already other company, so we collaborate Japan's return startups and the US startups. It's no problem.
Any other questions?
I have a quick question. How much does it cost you for you to send a trip to the space and come back?
Okay. Within 20 million Singapore dollar. Yeah.
And then what's the ROI for one of these trips? So what's the return of investment? So it's like how much rare materials, or how much worth of rare materials can you get back from one trip?
How much? Remittance. Okay. Sorry, I don't speak English very well. Yeah. I can transport one ton rare metals. Yeah. Okay. Sorry.
Do we have another question in the room, or was this just someone trying to see? Okay. Any other questions, or if you have any questions, then like feel free to contact Yoshi after the event. Yeah. Okay. Thank you so much. And then next up we have Charlie.
Do you want to press yourself or? Yeah, you can just use left right arrow.
Hey guys, I'm Charlie and over here is Harry. We're really excited to present you Re-Edu AI today, and we basically hope to revolutionize education with AI. So I think most of us know that it's very, the role of education is very important in the development of future generation, and that if there's really one error in the process, it can really affect the whole learning cycle and how students learn. So what we basically aim to do is that we actually talk to a lot of different teachers. And they said that the problem they face is that they spend a lot of time grading essays, and specifically they take about 15 minutes to grade an essay, and that's a long time. So take that for example for a class of 50 students, right? And if you were to grade 15 minutes per essay, that means it can take a minimum of 12 hours to grade around a class of 50 students. That's really time consuming for the teachers. So if you were to put it into respect, is that on the weekends, we usually get a lot of free time, to relax and kind of like wind down from social work. But whereas the teachers that we talked to, they said a lot of problems they face is, they're spending a lot of their free time on weekends actually grading students' essay. And what we hope to do is that we want to effectively bring down the time and effectively grade for students' essay without compromising, their personal unique writing style, and then we're providing a detailed feedback. So the cycle is really delayed because, as I said, it can take upwards of about 10 to 15 hours to grade the essay. And that, when the teachers really stressed and tired working under that type of condition, it's very difficult for the teachers to provide very clear and constructive feedback to the students. So if the feedback is difficult for the student to follow, there's no way for the student to go back and use the suggestions to work on their essay and then going back and constantly improve and work on their cycle. So on top of that, there's also a hidden cost that translates to about 200,000 USD for each school per year. And how this works is that if the school is instead allocating that time and resources for something else, such as building a service or a need to meet for students, such as providing more hands-on activities to really dive deep into the hands-on activity, it can really help to effectively improve students' learning cycle. A little background about the company is that we currently serve under 3,000 teachers and students, and our current market is the entire Southeast Asia, specifically in Singapore and China. And we're currently incubated under different organizations, and that has a global presence, typically for Google for Startups, NVIDIA, and MongoDB, to list a couple. So to head on into we actually have two services that we offer. One's a B2B section, and then I'll go into a little bit more about that now. For the B2B section, which is an AI essay grader, so how it works is that the teacher can upload the student's essay on the right-hand section. Like, it can be an entire class worth of document, and the AI will automatically break down the essay, student by student. And then over on the left-hand section is the teacher can select how the AI will be able to, the grading criteria that the AI uses to grade. And after the document has been processed, the AI will be able to automatically mark on handwritten essays, and this is where our unique technology comes in, that we have developed our own OCR system, is that it's able to mark directly on the handwritten essays no matter how messy the student's handwriting is. And over on the right-hand section is basically like a feedback that correlates to what you're gonna see in the essay.
Yeah, so let me dive a bit more into the technical details, which I'm sure for any tech personnel is more interested in here. So the reason why we pick grading essay as a subject or niche that we want to focus on is because STEM-related subjects or math-related subjects, science, is really easy to grade. You just compare the answers, A is an A, B is an B, a 3 is an 3. So when STEM-related subjects are so easy to grade, English becomes one that takes the teachers most time to process because it's very subjective. Every single essay, every single teacher has their own unique grading style. So that's why we developed this system where we can directly mark on students' handwritten paper. And not only this, we can also capture teachers' unique grading style, which is really important because after talking to so many educators, what they told us is that they are still proud of their work. They want to provide personalized and unique feedback to the students. So what the system does is that you will actually understand the school's grading rubric, curriculum, the teacher's grading style, and how these feedbacks are usually translated on students' handwritten paper, and we do that mimic directly. So any kind of these box or underline you see is actually generated by AI. And what the system is able to do is that on the right side, for every single you see on the left side, there is a detailed feedback telling students where it's wrong, how they can improve. And it's not only on grammar and spelling, it can also extend beyond that into context, how different paragraphs relate to each other. Now this significantly reduced teachers' time from up to 5 to 7 times. And from our paying MOE school teachers in schools, we realized that this is actually true from a real-life statistics. And beyond that, what we also do is that we implement a system that we adapt to teach students over time as well. Because as we grade students' assignment, we start understanding what's each individual student's unique strengths and weaknesses. Now, previously, for one teacher that's in charge of 40 to 50 students in one class, it's super hard for you to manage exactly how students are performing. But with these statistics, teacher can now easily understand, see which student is falling behind, which class is falling behind. Are there any missing information that the teacher are not teaching in the existing class? Yeah. Okay. So yeah, this is just quick testimonials from one of the MOE school vice principal that we're working with, as well as one of the English teacher. Yeah. So teachers been really loving the product because they said it not only helped them grade faster, but also it allows them to have more time to actually give detailed feedback that student previously just couldn't have. And then overall, the result we've seen is on average a 15% score increase on the school side, which we are extremely proud and happy to hear. I'll pass it back to Charlie to introduce a bit more on the B2C side.
So for the B2C side, which is our other product, is that how it works is the students will directly upload essays onto the product, and then it basically the AI grades the student's essay. So how it works is, it can basically grade a lot of essays ranging from O levels, A levels, and APs. So really, it does apply to a lot of different students. So there's basically three categories. The first category is grading, which the students upload their essays, and then on the right-hand section, it basically uses a rubric, whether that's O level, A level, to actually give you a grade of indication of what the standard of the essay is. So the second section is breaking it down sentence by section, word for word. Really looking at and if there's any contextual errors in the text and give suggestion based on that. And then for the third key point is the sample essay. So it's like what the essay would ideally look like with that you can obtain a full mark with. So on top of that section, we also have a knowledge bank, is where private tutors can use. Or private tutors is looking to see if there's any knowledge gaps that students are missing, like a word bank or filling in any rest of the contextual errors. Yeah, I'll pass it back to Eric.
Yeah. So the tech essentially behind this right here is what we call a RAG system, retrieval augmented generation, if you're in the tech space. Now what this means is that we create a vector database for students to input all their materials related to their class. It can be images, PDFs, PowerPoints, it can be their own handnotes. So with this system, what the student put in here, we can keep track of everything or every knowledge is related to what the student is learning. Because every single class, every single school have their unique curriculum and the way that teachers teach. It's impossible for a generic model like ChatGPT to teach all the students at a personal level. And that is where existing large language model is lacking at. That's where we want to focus on, is to provide a very personalized tutor that understands how students' existing assignments are performing together with what they're learning at school. So what the student can then use this information is that they have an intuitive AI chatbot or AI tutor that they can directly interact and see if they're missing out on any information. And everything that the AI tutor teaches student is based on what they are learning, which is coming from this vector database. So every time the AI is providing an answer, it's going to be 100% accurate, and it's going to be 100% related to what the students is learning in school. And if I just wind back one slide, this is another cool technology that we built, is that we are actually able to generate very accurate models or graphs for students. So what you're seeing right here, this is actually an A-level economic student. What we're able to do is that we created with top-level tutors that are already seeing tractions of helping students to improve significantly or a short amount of time. Is that we provide very detailed feedback and then exact key points on what helps students score. And with this technology, students is able to see about a 40% score increase within just 1 month. Because students can use this to self-study, they're able to pick it up very quickly. One of our students previously studying, receiving about an average C grade. A month later, they're getting an A. And again, we're super happy to see this result. So moving forward, beyond just essay grading, so the essay grading is one tool that I really want to focus because that's where we are unique and that's the niche we want to focus on the market. But beyond that, we also do other kind of support for schools. That includes assessment planning, AI curriculum planning, course planning, designing. So we can do a lot of customizations for schools based on their needs. And here's just our current global outreach or current distribution network. We're connected with about over 100 schools, mainly in Southeast Asia. We see Singapore, Indonesia, Thailand. We're also recently expanding into Vietnam. Then we have connected schools in China as well as US and UK. I know there's like a wide range of people here today. I think there are investors, developers, there are founders. So I do want to just share a quick detail. So we are a pre-seed company. So actually we are raising. So for any investors out there, if you are looking at investing in pre-seed startups where you are connected with schools or investors, love to connect. This is my contact. Feel free to drop us a message. We'd love to connect with you. Thank you.
Any specific questions from the audience?
Yeah, so first of all, congratulations on getting into the pre-seed. I think it's a good achievement.
Thank you.
I think one thing some of us are probably asking, we would like to have seen some evals. Are there any evals towards any of this? We don't see any hallucinations for us to contribute to this. The second question being, when you mentioned B2B, I think that was alright. But once I found out about B2C, then I was thinking, wait, so students are also using a similar product that the teachers are also using to mark? So are the models actually just agreeing with each other in that sense? showing what sample essays can be about. I don't know if I was a parent, if I can see what is the creativity level that can be in my kids, because essentially the workflow I can think of is I ask a general model to spit it out, I put it into B2C, and then when B2B marks, it's probably going to put me in an A grade straight away. So yeah, those are my two questions.
Thank you for the question. So I'll answer the first question first. In terms of the evaluation, what we typically do is that we benchmark with each school's their existing papers. So usually during the setup process or customization process, what we do is that we first understand what's the school's curriculum, their grading rubric, how they usually provide feedback. So we make sure that we are aligned with how the school and teachers are currently grading. Then we will take some essays, existing papers from the school, the marked ones and the marked ones. We'll use that to benchmark the system. So we'll evaluate our system to make sure that we're providing the same level of feedback that's aligned with how the school is currently doing. So that's how we eliminate hallucination, and that's how we align. And then in terms of the second point, that is also a very interesting point that was actually recently brought up at a roundtable discussion we hosted, which is how would parents feel about their students using AI? Your concern is about, are they following a similar model in terms of grading? The answer is no. So on the school side, the B2B solution, everything is customized to the school. So that is aligned with the schools and teachers' specific grading style. And the B2C solution is a model that's aligned with the exam board standard practices. So what the students is learning from the B2C model is what they would be learning from schools already. So that is a standard teaching curriculum that's applied to every single student, and that is ensured fairness. So there's no cross-communication between models because they're trained separately, a different data set, such that even if students score well using the B2C model, it doesn't necessarily mean they will score well, because that's, again, based on the teacher. So if that teacher will mark harshly, just don't like your type of essay, again, you're not going to score well on that. The second part is, providing a sample essay for students to learn is going to help for the students. So the B2C one right now, we're currently targeting, I would say, the higher level students who have stronger self-learning ability, who knows what's right and what's important for them. Students choose to adopt this B2C solution usually means that they know that they are lacking in this area. That's why they are willing to pay to actually improve and let a system to evaluate it. If people want to cheat, they would just use ChatGPT or generic free model to generate an essay. They wouldn't go into the effort to pay for additional solution, let it evaluate you, and then give you a model answer. In fact, there are way more model answers online that the student can copy, and usually if you just copy a model answer, you're not going to score well. Because school exams or exam board exams are typically designed in a way that model answers doesn't work, because it needs your unique, I would say, on-the-spot thinking ability. Yeah. Oh, yeah, yeah.
It made sense earlier, actually, when you said that, I thought that the same model is helping grade, and the same model is teaching, like sort of the same engine. Because mentally I was thinking that then the child is learning what the teacher likes or what the school wants to teach them. But now that you said that it's completely separate, and they're learning what they were supposed to learn through the exam board method and all of that, don't you think these are two completely separate businesses in that scenario? Because why get into B2C at all? Why not just do B2B? Because I think a lot of edtech companies are trying to tackle it. So what is your differentiation there on the B2C side? Because B2B understood, right?
Yeah.
But
Definitely. So the differentiating factor for B2C, or why did we get into this field, is because as students ourselves, so we're currently university students at National University of Singapore. And before that, we were doing all these exams. And what we realized is that we actually need a lot of help from the teachers. And that's how we actually even first discovered this problem. It's when we are practicing, when we are doing exams, we realize it's really difficult to get feedback from our teachers. The feedbacks on our paper is vague, it's delayed. So every time we finish an exam, a month later we get the feedback. And we already forgot what we wrote, what's our process. So the feedback is not really helpful for us. So as a student, we started talking to teachers, and we realized, teacher, it's not that they don't want to give us feedback. It's that they actually don't have time to give us these detailed feedback. It's just that it's so a massive amount of administrative workload for them that's just impossible. So that's why we first started developing this B2B model to help the teachers. And then we realized, okay, students are, because we actually teach students, some of our team members are private tutors previously. When they're teaching students are coming to us, we're like, hey, you are not having this tool to help teachers. Can you have built something to help us for us to study and improve ourselves? Because we're studying, because students use ChatGPT a lot. They're like, what I get from ChatGPT is just an answer. That's it. It doesn't tell me how to improve. It doesn't tell me how to write. If I give my essay to ChatGPT, all it tells me, hey, your grammar is wrong. You can write it better. But I don't even know if that's aligned with the curriculum, which is what generic LLMs are bad at. So then we built this B2C model in a way that it's one, aligned with their A-level or IB AP curriculum. And second is that with that vector database, they can learn with their materials from the school. So it is true in the sense that the grading mechanism is separate from the B2B side. But in terms of the teaching, in terms of the self-learning ability, the B2C model functions way more advanced or way more, it's slightly more superior than a generic ChatGPT LM model. Yeah, hope that answers your question. Yeah.
And I think we don't have enough time for the other questions. You can just contact Harry directly.
Yeah, just throw me a message. Love to get in contact with you guys. Thank you.
And then next we have presenting on Molly's energy efficiency. Is he in the room?
He gave his number. Oh yeah, sorry. He was. Let's take a bit. Wait. We just get Rachel to present first. We just get Rachel to present first.
Are you sure?
Actually,
How long does he need for setup?
it's fine. Can you set up in the next 2 minutes?
Yeah.
Do you want to connect?
Yeah, you can. I think so. I think it's a different connector.
Different connector?
Yeah. Do you have a Type C?
Do you have a Type-C?
No.
Type C. This one.
Let me have it here though. It's fine, it's fine, it's fine.
So, very good evening to one and all present here. My name is Om. I'm a BTech graduate from Vellore Institute of Technology, India, Chennai, which is my place of engineering. And today I'm going to be speaking about why do we have the oxygen level need of energy efficient models, and why are they a boom in the IT industry? So this is my thought, like I just made it up one day, and I just felt like, like in this IT domain, we really have a lot of problems. Among them, this is the main problem. If this gets solved any day, which for a general purpose, we cannot idealize this thing, we can generalize this thing, but we can actually make something which is close enough, which is really efficient enough. We should have the value for our resources which we have. And when we make these models, right? So when we make these models have to be energy efficient. no matter in whatever domain they are. We are handling healthcare, we are handling military, we are handling tech, data centers, we are handling what not. There are countless numbers. I myself would forget to even mention many of them. So, yeah, so I would just skip. So the reasons why do we actually need energy efficient models, like there are environmental benefits. That's why I just told at the starting, like we need oxygen level need of energy efficient models. And these energy efficient models, basically, they have to be custom based, task based, depending on a task. It just changes again and again. And how can we actually implement these models or make these models? We're going to discuss that. And for discussing that, we actually have some experimental. This would go someday. This would be a disaster one day. Like if you don't really make your energy models, energy efficient models, especially. So the techniques to make an energy efficient model could include your neural architecture search. So neural architecture search is basically what? Like you would actually pick a particular model with a certain architecture and with certain features that suits as per your task, which is varying, which is different from one place to another place. And you have pruning, you have quantization, you have fine-tuning up to one extent, like it doesn't work always. None of the other techniques always work. And there are some techniques which work at different situations, for different tasks, for different models. And so I would have one small rapid fire question. Which among the below is a better to use model? Just think as a general purpose. Which one would you prefer and which one do you think is good?
One on the right.
Okay, anyone else? You can tell your answer and what do you feel about it?
Depends on the use case.
Depends on the use case. Depends on what else? Anything else? Anyone?
Like if I'm asking a medical question, I need it to be more accurate. But if it's a general question about something and do on a Google search, I would prefer a less modern one.
I always choose the one on the left, unless the one on the right is 100x
100x more. But you realize this one thing, like give a thought, you do have available resources, that's why you tend to make models, right? You have resources. But if someday I say you have a model, you have a good enough model and it's energy efficient, and you could even fine tune this model, and you see that this model, even after fine tuning, it's taking lesser memory space than this, lesser energy resources, lesser available resources, which is used for implementing a model. So any day if I say you, like a model B, it does have only one aspect. I just mentioned purposely that one aspect, which is accuracy. But if I say I need more memory saving, more energy saving, more resource saving, if that was the case in general aspect, you would always still prefer a model which is efficient, right? Because it saves high computational costs. It saves many other things as well. And yeah, so that's the thing. You would go with which model? Kind of need a vote of type. Vote thing. It's
We can raise our hands, the ones who say accuracy.
yeah, you can raise hands. Anyone who feels like model A is better? What's model A? Yeah. And model B. So it was actually, it's a neutral question. It's like a general way. It depends from task to task. There's no specific answer for that. But I just kept the models. Let's just show them it's a general idea. And I would actually explain something related to energy efficiency, which these models were compared on. They were variants of CNN models, and this was one of my final year projects which I had worked on. I was actually dealing with energy and memory consumption of these models in depth. It's not like just a model as a overall it's consuming and it's just giving the value and that I'm making my decisions. It's actually a in-depth, I'll just skip all this, it's not really. It's an in-depth analysis of layers and sublayers in a model architecture, which is there. So you need to have in-depth level of knowledge and details when a model is being analyzed, it's been deep dived, it's been broken into layers and sublayers so that you identify how much each and every layer and sublayer consumes the energy, which constitutes the model. Okay. Right? So this was not a correct result. This was a pattern which we had observed. Like even if we got a correct result, the pattern would be somewhat similar to this. And the issues, this was the main issue, like we had a GPU, we had like some NVIDIA GeForce RTX 4080, which was supposed to be overkill for the research work, but it still struggled and it still skipped layers. And thing is, these results are not accurate. But we fixed this issue and brought the layers down to less than 10 layers. We had like some 8 layers skipped. And this pattern was like, you can see that the total energy and the forward pass energy, either they should, like total energy must be always greater than or equal to forward energy. Or it has to be something related to that. It cannot be like forward pass energy is just greater than total energy, right? And how does the model even work? So like for easier clarification, like you can see VGG 16, ResNet 50, EfficientNet V0, DenseNet 121, AlexNet. These are all CNN models. And these were all famously known models. People have optimized a few models to handle complex tasks. People have not modified some models because they were already initially good in handling complex tasks. And they vary through their architecture, they vary through their efficiency in terms of resources like energy, memory and whatnot. There are like internal resources also which they use, which I also won't have idea of because I just was dealing with energy and memory as of now. And yeah, you could see this was the entire thing. This was the actual entire thing when each and every layer was considered. I actually couldn't consider those 8 few layers during that time because those layers were either following a concept of ResNet. If you know, like ResNet skips layers, that's a model just to improve a training time, just to improve its memory usage, just to improve its energy usage. Or it finds that the layers are useless because you could have even done your task without using those layers. So this is like a breakdown of all the layers which got considered. There were like some 8-9 layers which was getting skipped, but it was like a thing of ResNet. So even if it was not considered, it was still giving an equivalent result. These are all the details. And yeah, we actually tried running it in local GPU as well as cloud GPU. My teammate who is Sharon, he's in Dubai and he recently came to Chennai for a few weeks. He was helping me with the algorithm implementation and he had the GPU in his laptop, whereas I didn't have. So I had to actually access the Colab Pro version, which actually provides me the NVIDIA L4 GPU, A100 GPUs. And we could actually see a difference in the performances as well. And we also got situations where we actually got the exact same values. But it's always recommended that you have a local GPU because local GPU definitely takes much lesser time than actual GPU. I mean the cloud GPU, local GPU is definitely worth it. And cloud GPU is even expensive, so it's like too much. So this was an algorithm, you don't need to deep dive, but this was like the steps which we had performed. AlexNet was separate thing that we had to mention and stuff. And yeah, like this algorithm would work for having the energy analysis, memory analysis for all the models, which like only your model syntax would change. You can always use this code. There's a code for it. I will be actually sharing you the code You can actually compare any of the models. And yeah, that's the thing. Like you can, before implementing any of your tasks, you can have your projects doing some tasks, you can have computer vision tasks, natural language tasks. So you can check which model actually is energy and memory efficient before you try to even do the task. Isn't that better? But it still uses some GPU, but you can always have a note on that. And the research paper for the very same thing has been won for publication. It's under progress. And yeah, let's hope for the best. This is just the main steps, you know. This was the main thing actually for a brief explanation. So our incomplete mission, and we still aim to achieve, what was it? Actually, we wanted to make a hybrid model which was energy and memory efficient and was better than all these models which we took into consideration in terms of time, energy, memory and everything. So I would like to end the session just by saying that these were the challenges which we faced. And these challenges were this was actually our break point, and we were able to overcome by making a shorter code, by making a more least dependency code. Your system should never say any day you don't have this software, you don't have this hardware. Our code should be made in such a way that we have the least dependencies, we have the easiest integrations possible, and must be working on each and every system for the analysis of which model we should take in our future upcoming events and our other research project works which will be done by each and everyone in some modular point of time. Thank you and have a nice day. That was everything I had to say.
Any quick questions from the room? We have time for just one quick one.
Just wanted to understand, so what you are proposing is your code basically helps analyze the energy usage of other models, or you are providing a better model, more energy efficient?
Our actually task was to perform getting the energy classifications and whatever in-depth layers distribution was there. And we also wanted to make hybrid model. But the biggest issue which we faced was resource availability. That is the GPU. We don't have enough GPU to make a model, enough power supply to make a model, which can compete models like VGG16, AlexNet, and all those models. Because these models themselves were either made by Google, Facebook, and they were on continuous power supply for 2 to 3 weeks, on GPU resources for 2 to 3 weeks. So it is actually pretty hard for an individual to get all those resources and make a model. Otherwise, he or she would have started a company right away.
Thank you so much, Ron. And next up, we have John. Oh, it's okay. I'll stand over there if it's getting closer.
Maybe a minute before.
Yeah.
Hi everyone, I'm Jun from SampleApp.ai. We work with API companies to basically help them onboard developers to their public API in 60 seconds instead of taking weeks. So just to kick things off, could I have a show of hands? How many of you guys here are founders? Okay, awesome. How about among all of you guys, how many of you guys are developers? I thought there's more though. But keep your hands up. So as a developer, do you like reading documentation? If you like reading docs, keep your hands up. Okay, I respect you, bro. Yeah, so now to get things started, so this is an activity I would like to do with you guys. So as a developer, imagine as a developer, now you are onboarding yourself to a new API like Stripe. And basically there's 2 buttons for you to press. The first button is to book a call, to learn more. And the other button is to basically click try out. Could I have a show of hands? How many of you guys would click the book a demo? What about for try out? Exactly, so that's the problem. Developers love to try out new API because they're cool, but nobody's going to book a demo. So if your company has API, how do you get them to adopt and onboard to your API? So that's one of the biggest problems that we are tackling. Getting developers to onboard new public APIs fast with superb developer experience. So I spent the last whole year at Silicon Valley because we are like a startup backed by Alchemist, one of the top B2B accelerator in US. And this is a common problem that we hear over there. And I think today, I just want to briefly share with you guys what I think about this problem. So firstly, developers hate reading documentation, especially whenever it's outdated. Unless your docs are extremely good like Stripe, most of the time developers really hate it. The second problem that I noticed is that developers are extremely sensitive to every single button on your website, and they expect really superior developer experience, and they want ability to try out your API. Thirdly, we just hate salespeople, and booking demos just sucks in general. So these are some ways that I noticed that companies are trying to solve and tackle this really difficult problem. The first is to introduce AI chat. So most of the Bay Area companies all have AI chat that is built on top of Menlify or Fern. And AI chat is extremely helpful because a developer can just type in any prompt and get answers to the questions that they have about the docs without reading docs. The second way is AI code gen. There's been a rise of platforms like V0 and Cursor that allows you to onboard to any API, and all they ask you to do is to upload your documentation onto Cursor, and you basically can start building. The third and most unique method that I've seen in the market is by this company called Convex. Convex basically helps you settle all your backend integration and API. So what they did was that they built this platform called chef.convex.dev. You guys can probably check it out. But when you go to their platform, instead of you going to read through Convex documentation, all you have to do is to say, I want to build a front-end e-commerce website with Convex backend, and basically it builds for you the entire app. You can preview it and run it on that platform. So these are some of the really cool strategies that we see in the market today. But there are some key problems with each of them. For the first one, for AI chat, a developer can onboard to your API by asking questions, but they can't onboard in terms of generating code or app with your API. Second, if you're using Cursor or V0, I think you guys probably have experience where you upload the docs and it just doesn't work time after time. And the main reason is because the web scraping that Cursor does is just as good as the web scraping itself, because they don't work directly with API companies, and sometimes it may lack the latest API knowledge or outdated API information. Lastly, you could try to build a platform that is an entire prompt to app generator like Convex, but it's extremely expensive and it's actually hard to maintain. If you're just a company that does a payment API, why would you want to spend all this effort to build it? So what we see at SampleApp.ai is what if you can do these three things. First, what if developers don't have to read documentation and can onboard to any API just by prompting, and instead of just getting an AI chat, they basically build an entire app. Second, a developer can now build an apps very safely because the entire playground is trained on the API by working directly with the API company. Lastly, you don't have to spend money to build this platform and maintain it when you can build on top of something else that already exists. So that is what SampleApp.ai is as a nutshell. And what we do is that we basically have an app builder that is trained on a company's API, knowledge base, documentation, support, requests, everything, and basically allow any developer to onboard themselves to any API in 60 seconds. And a developer simply just go to a playground, train on a certain API like Stripe API, and say, build me an e-commerce website using Stripe API and SDK, and it builds for you the entire website, and you can preview it right on the spot. So this is what you see if you log in as a developer. All these playgrounds are free because they're just paid by the companies, so you can just try it out and build any apps directly over there. So there's some of the playgrounds that we support are like Stripe, AgentQL, Grok, Daytona, Zoom, and a few others. So as a developer, you can build in different frameworks. You can build maybe an e-commerce website, you can build maybe like a web scraping website, a price comparison website using our platform. We support Next.js, Fast API, Flask, Vite, and Python. And basically, it's as simple as just prompting. So let me just quickly show you guys a demo over here. So over here is basically a playground that is trained on Twilio API. Twilio is an API where you can use to call to basically send messages and all. And over here, all you have to do as a developer is simply say, build me a mockup of Twilio API, and I want it to be like a full mockup. And once you press enter, it will generate the entire app for you. And you can basically edit the code, you can preview it, you can test out the app, all within the same platform. So one common use cases we see people is that when they're trying out multiple APIs, they simply like open 5 tabs, try out all the different use cases, and quickly preview all within the website. And it's as simple as that. So once done, you can even have a public URL that you can now share with your friends. So everything is live and on a working app. So just another demo is basically like using Stripe API. So basically, this just shows you how easy you can set up a playground by just uploading your API knowledge and basically say that I want to build a Sephora website just by uploading your Stripe API SDK or OpenAPI spec file. So likewise over here, I'm just trying to generate an app. Before I move on to like a live demo, because I think videos are pretty boring. So we are basically giving away some like vibe coding t-shirt over here. Because we basically did a hackathon in SF and hosted like 400 people, and we just gave free t-shirts for the winners. So we have like 2 t-shirts here to give away today, and just basically scan this QR code and fill out this form, and I think at the end of the 10 minutes, I'll basically pick 2 winners. So maybe I'll stand here so it's easier. So let's go to the live demo over here. So over here, one of our customers that we're working with is this company called Daytona. Daytona basically allows you to call the API, and when you call the API, it helps you to allow your agents to run code in a sandbox environment. So this is a playground that we built for Daytona, and basically when you go to the playground, you are able to select what kind of frameworks that we want. So you can, as a company, you can customize Next.js, Vite, Fast API, and Flask. And for them, they just wanted Next.js. And after that, you can type in, say, build me an app using Daytona. But I can't really type now, so I'll just click on the default prompt over here. So when I click on that, what happens is that it basically just brings you to the next page and starts planning and understanding your requirement. At the same time, it's also looking through the API documentation to basically extract out the right information to build this app. So over here, you can see the entire app being built. And on the right is an entire line editor, which later you can see that you can edit. There's also Git diff as well, and you can search through the whole documentation. So once it's done generating, what you'll see later is something like this, where you have all the files being generated. You can actually click through and basically look at every single file that is generated over here. So you can see that it's making an SDK call to Daytona SDK, initializing, and basically creating a sandbox environment. There's also changes that can look for the difference. And at the same time, like once it's ready, you can click on preview. And how it works is that instead of you using .env, we make it a lot easier for you. You just get the API key and you can just provide on the left here and just click submit. And once you click submit, you can see the entire logs of the entire app that's running over here. So this will take like maybe like 2-3 seconds because we are basically running an entire container in the cloud right now. So once you see app compiled, you can see the entire app ready over here. So you can click on create sandbox, and this is actually making like an actual API call to Daytona. So when I click run Python, it actually provides this code to Daytona API, and right now you can see that it's basically calling Daytona API running the code. So this is as simple as like 1 minute just to onboard yourself to Daytona API. And for companies, they control the experience that developers get. As a developer, once it's done, you can click on the publish, and this is a public URL that you can open on incognito, and basically you can share it with your friends. You can also click on fork to basically fork this chat and build on top of it. You can also click on download code to basically save it to your local environment to probably run in Cursor or something. So after that, you also get a public URL that you can share. So let me just go back to here. So what I shared just now was basically a ability for you to generate like an entire app just by prompting, and you can use the default prompts here. Now what I'm going to show you is that having a community of apps that is being built by your friends, your peers, or by the company that is being listed over here. So it's a very community-driven platform where basically you can see sample apps that is being built by the company or sample apps that is being built by your peers. So this sample app is about running Python code, the other sample app is about executing Node.js environment. So when I see an app that I like, I can simply click on live demo, and it basically brings you to a live working sample app for the API. So you don't even have to spend hours to figure out what to do with this API. And let's say that this is an API that you like, you can click on the fork chat, and it basically opens up an entire chat for you that you can now build on top of work that's done by others. So this is something that we feel would allow you to quickly try out, experience any API, and onboard yourself really quickly. So the second example I want to show is a company that we're working with. They are called Statsig. So they are like competitor to Post-hoc, and how it works over here is that instead of you spending hours to find out where's the API key, which often is quite difficult, I have no idea why, you can basically click Get Statsig API Key. And what we did with Statsig is that we partnered with them to build this entire OAuth experience where you just copy this verification code, click on the console link, and basically click Submit and Authorize. And let's just go back and just wait for it to be authorized. And now you have the entire EMV key for your Statsig API. So for companies, they don't have to worry about developers not finding their API. This experience is just inbuilt within the playground itself. So it's extremely catered for any API company. So yeah, I think that's all that I have for the demo. Happy to answer any questions later, but I will just quickly go back to the deck. Yeah, so how it works is very simple. If you want a playground, like as a developer, if you want to try it out, you can just log into sampleapp.ai and create an account for free. You can try out any of the playgrounds that we really support. But if you're a company and you want this kind of experience for your developers, you basically work with us. You provide us your API spec file, and we'll train a playground for you. Once you have the playground URL, usually what we see is that companies will either list it in their documentation, put it on their console page when developers log in, or even put it into their marketing emails to help improve conversion. So this is just a hackathon that we sponsored in SF with 400 packs, and these are some of the apps that people were able to build. And for context, these two apps were being built by business students that had no idea how to code, so that they technically just bug coded that whole shit. Sorry for the language. Yeah, so like as a company, instead of not knowing what your developers are building, you actually get insights into what kind of frameworks are they using, what kind of use cases are they doing, and that's basically just a very high-level overview. So we are being used by very leading developer companies like Statsig, Quadrant, Daytona, and backed by leading investors from Alchemist Accelerator, and the ex-CTO of Salesforce, and VP of Marketing for SourceGraph, JFrog, and Neo4j. So developers love us, hopefully. And yeah, that's all that I have. I think I'm time's out, so I'll just basically pick a winner from like the giveaway, and I'll just text you after the event. Yeah, that's all I have. Do scan this QR code to check out our website. Thank you.
Do we know who's the winner right now, or you're gonna text the person?
Do I have time?
Well, we have time for maybe one quick question. Anyone has a specific question they want to ask? Okay, this presentation will be by Daniel from Menlo.
Okay. Take a super. Sometimes. Oh, oops. Was it okay? Really? Thank you. I don't want to see the whole presentation. Oh, thank you. It's a bit different from the regular.
Hey everyone, I'm Daniel Cheng from Menlo. I'm currently an intern there. So today I'll just be talking about two things, just Gen Beta and our newest model, Gen Nano. So all of these can be found online actually, and let's just get started with Gen Beta so I don't hold you guys back from getting kicked off the library. So I think the main things that Gen Beta offers is to take one step back, Gen is essentially what we envision, a digital assistant that does all your digital work for you, and there are steps that we have taken to, reach that goal. So Gen Beta essentially offers the following features. So, running local models, we have like a model hub that we have integrated into Gen. We offer remote model providers, so you can see over here that we have like all the remote model providers, OpenAI, Anthropic, Cohere, OpenRouter. And we have assistants in which you can kind of customize like different assistants for like different parts of the job. And I think the most exciting thing that I personally found to use a lot more was MCP support. So again, I'm just like gonna breeze through all of these so that we can get the demos and we can actually see Gen Beta live in action. So let's just get to it. Cool, so what I have here is Gen, and currently what I have loaded in Gen is this Gen Nano model that the research team has trained. It's a 4 billion parameter model, which I'll talk a little bit more. And just to give you guys a comparison, a 4 billion model in terms of parameters is about 100x smaller than your run-of-the-mill GPT-4o or 4.1, and we're going to see like the amazing things that it can do. So over here, I have like this. I have like a blank browser screen that would show you that the Gen Nano is actually going to use the browser for you. So I'm going to say, I actually have prompts. 1 second. Navigate to Gmail and summarize yesterday's emails for me. So this is going to run on my local computer. And while it's running, you can see that there is an uptick in my GPU usage to show that it's like actually not calling any endpoint, but it's actually running on my device, and also because I don't want you to see all emails. So I recently just shipped an iPad to my house, so that's like, again, I guess you can see some emails. But you can see that it's actually pulling data, and it's actually using, like the data live in front of your face. So that's like kind of what that's like a very clear step that we have taken to like using, for Gen to essentially use your computer for you. The next thing that I'll show, also running on my local computer, would be to say, what are the top LinkedIn posts on my feed? And it would navigate similarly to, okay, let's try that again. yeah, so again, while it's running, like it essentially uses like it's essentially, or like I guess an explanation, a quick explanation into how it's actually working. It's like you actually have like a browser MCP Chrome extension that you install in Google Chrome, and then essentially whatever that you have logged in on your Google account, you know, like the Gen can essentially use the browser for you. Yeah. So I think that's cool and interesting, but now I would like demo something that honestly it's like really new, like something that the research team just pushed out this afternoon. So beyond just running local models, we actually allow you to add your own remote endpoints. So what I've done, yeah, so you can see that like it essentially pulls up the LinkedIn post correctly. What we can do as well is to essentially add your own model provider. Say like you have your own infrastructure. What you can do is to add your provider, and essentially what I've done here is to add like the endpoint in which our Gen Nano, like the newer version of Gen Nano is being hosted, and I'm just gonna demo it to write a report for me using a different MCP. So in this MCP configuration, you can essentially choose like what MCPs you want the model to have access to. So so that was like running on Llama CPP, and I'll just go all the way down and use Gen Nano Research Endpoint, which is essentially hosted on our own silicon. And I'm gonna say write a journalism level report on the latest issue regarding Trump's tariffs. Yeah, so it's gonna go through like a list of websites, and essentially you would think that a 4 billion parameter model wouldn't be able to output like deep research to the levels like OpenAI does, right? Like there's essentially like a whole pipeline, but essentially what the research team found is that if you train the model to be really good at tool use, it can actually be a pretty good report generator as well. So yeah, usually it's actually a bit faster than this, but yeah, you can see that there is a structure to how the report is generated, essentially. Yeah, I'm gonna stop right there, and I'm gonna show another use case of like using. Sorry.
Is this a reasoning model?
No, it's not a reasoning model. Yeah. Okay, while it's running, does anybody have questions regarding this model? Like, yeah, sorry. Does anybody have questions regarding this model first? Yeah.
Yeah, just wondering. Just now I saw there's a transcript summary.
Yep.
Right.
Yep.
Why don't you guys like apply the ASR to?
Oh, so we actually host like Whisper ASR on our own endpoints as well, but audio is not something that Gen currently supports, but it's definitely in the roadmap for it. Yeah. So that's actually like whatever that you saw in the transcript just now is actually being run on our own silicon as well. Yeah. It's a Whisper small model that's running on a GPU hosted in like Kaki Bukit. Okay, cool. So now that this is done, let's switch to like a really powerful model and like give it, access to the browser use and turn off. And I want to find out, something to what I'm a big fan of like open source intelligence, something like what Rachel was demonstrating just now. So I want to keep up, with like the latest developments in the Israel-Iran conflict, right? So I can say, I've specified like the assistant that I've kind of configured. So you can essentially configure assistants. And I want to say like, what's the latest news on the Israel-Iran war from OSINT on Twitter. Yeah. So it would essentially navigate to like what I believe is verifiable and trustable Twitter profiles, and it essentially like kind of pull the data from these Twitter sites, and yeah, like essentially like it'll give you a almost like a real-time report of like what's going on, even when you don't have like even when you don't need to like essentially consciously keep checking Twitter for the latest updates. You can essentially ask Jen to do it for you. So that's essentially what Gen Beta is together with Gen Nano. And so I guess a little bit more details about Gen Nano. It's a 4 billion parameter model that's trained specifically for 2 use. The base model is based off a Qwen 3 4 billion parameter model. It's fine-tuned with DAPO. The evaluation is based on simple QA, and the technical report is coming soon. So if you guys want to find out more, like these are all the links. And if you want to like ask questions regarding the research behind Gen Nano, please ask in the Discord chat. Because if not, the research lead would kill me if I answer anything. So hope you enjoyed it. You guys can download Gen Beta and use it essentially on like any computer. Like right out of the box. So yeah.
So that's all the presentations we have for the day, and thank you all so much for coming. If you have any specific questions about Gen Nano or Gen Beta, like, come to us. Thank you.
Hi.
I just wanted to know what you guys like Menlo Park, what it does. I saw it was an open source.
So we actually Menlo research, but we have the inspiration from, I guess, Menlo Park. We're essentially like envisioning like a post-work future. So we have like different ways to achieve that goal. So there is like our digital assistant that does everything for you, which is essentially Jen, and then we have like our physical arm that like does all your physical work for you. So that's like
you're a for-profit company?
We will be a for-profit company. So currently we're pretty much revenue. We are like a team of like 24 to 25 people. And feel free to like check it out. It's free from the open source.
Can you put in like any MCP server?
Yeah, exactly. You can actually configure like your own MCP servers. So just go to like MCP servers and configure it here. And if you want, you can kind of like gibberish, dada, save, and you can edit the JSON here. That's something that is. Yeah. Hi.
This is Jay. I had mailed you.
Nice to meet you.
So I say hi. Like great work on the.
Thank you so much. Yeah, sorry that we couldn't.
No worries. Yeah, I'll hopefully be back and then.
For sure. Just email like an official piece.
Perfect.
You'll definitely translate you in.
Perfect. Thank you so much.
For the Gen, you still need a GPU, right?
So I mean, I'm running this on like this is like a high RAM computer. But what Apple does is that they don't actually have, like CPU and GPU. We have like a unified. Apple has a unified, RAM. But on my other Mac, it's like an 8 GB RAM. It's very small. Essentially, what I would do is that I would just run like a smaller model. So like maybe like a 1.5 billion, 0.5 billion for every RAM.
So all these are paid or?
Oh, it's free. Like you can actually download it.
Okay, let me go and try it out.
Yeah.
Oh, so you do? I'm not running on Mac. My office is running on your Windows. So
It should work.
Right? It's not going to go like this.
No, I don't think so. Yeah, maybe the beta, like our support is our beta is not super fleshed out yet. But again, like we encourage like you to just like ping the Discord team and like just like show all your grievances to them.
So you're still studying?
Oh, I've not started studying, but I'll start. Yeah.
When?
Probably like Waterloo in Canada.
Yeah, LinkedIn's great.